Welcome to the Verisk webinar, Assessing the Liability Risks of Generative AI. Currently, everyone should see the opening title slide. The material will take approximately 45 minutes, and you may submit questions at any time through the chat feature. To access this feature, click on the chat bubble on the upper left side of your screen, type your question into the text field, and click Send. The presenter will follow up with you directly via email following the webinar. Presenting today is Eleanor Bragg and Greg Scoblet. Eleanor is a research analyst in the Arium Liability Analytics Group at Verisk Extreme Event Solutions, where she conducts research to support the development of emerging and reoccurring liability scenarios. She has contributed to researching and modeling the liability risks associated with a range of issues, including chemical exposures, defective products, corporate fraud, and climate change. Greg is a writer and researcher with Verisk's Emerging Issues team. Greg came to Verisk after a successful journalism career, writing about technology, photography, and consumer products. Today, Greg is responsible for research analysis and content development for the Emerging Issues team, helping insurers keep up with evolving risks facing their business. I will now hand it over to Greg.
All right, and thank you all for joining us. I'm going to start with a quick reading of the Verisk policy statement. The policy of Verisk Analytics and subsidiary companies is to comply in all respects with federal and state antitrust laws. With this in mind, we want to mention that during all seminars held under our auspices, this policy prohibits discussion of certain topics. Because we want to avoid even the appearance of an antitrust violation, we go beyond the letter of the law and will not discuss any matter that violates the spirit of the antitrust laws or could be perceived as doing so. You can view a copy of our policy statement on discussions at meetings at the link on your screen. Okay, so let's get started. We divided this presentation into two parts. So my colleague Eleanor Bragg from our Arium team is going to discuss the possible issues that can arise from potential flaws or errors in generative AI applications. And then I'm going to pick it back up for part two and discuss some of the possible issues we see when generative AI is working fine, but falls into the wrong hands or may be used to influence a trend like social inflation. And then I'm going to wrap that up with a brief discussion of some of the potential longer-term risks that could come from AI. But first, let's start with a short introduction. So we're not going to focus on everything in this slide, but just a little bit of background so we're all on the same page with how the technology works. And this is going to become important as we begin to discuss some of the potential issues with this technology. So generative AI is a type of artificial intelligence model that can create new content from user prompts. That content can be images, videos, text, computer code, and more. So how does it work? Well, first, these models may be trained on an enormous quantity of data, and that data can include some of the inputs we've listed on the left here. It can also include large amounts of public data taken from the internet, or even potentially private data from other sources. And then using machine learning techniques such as generative adversarial networks or a type of neural network called a transformer, these generative AI models are trained for a given task. So for a chatbot, you may have a language model that uses a transformer to help it more accurately predict the next word in a sequence of text. There's also the potential for these models to be fine-tuned on more specific data sets. So let's say you have a chatbot that's trained on a large portion of the internet. You can also take it and fine-tune it on documents that may be specific to a given business or an application, so that the chatbot provides a more industry or business-specific response based on the training on that more tailored data set. So when your model is trained and ready to be released, there are two general approaches. The first is open source, where the general public can access the underlying source code and training data, or there's closed source, where the public cannot. So this distinction has important ramifications for questions around AI safety, ethics, and government. Some proponents of an open source model have claimed, for example, that without access to the training model or the data underlying it, it can be difficult to determine the extent to which copyrighted or otherwise private material was used during training, or whether the outputs are being generated from biased content. On the other hand, proponents of closed source models may argue that the technology is becoming too powerful to make its inner workings widely available, lest bad actors get their hands on it. So how do you generate anything from a generative AI model? Well, you have to prompt it. That's basically ask it a question. And there are a variety of prompts you can use, listed as some we've listed a few here. The actual types of prompts are less important for our purposes than the fact that there are multiple types you can use to elicit information from a generative AI model, and that's going to become important a bit later on. And finally, there's the output, which, as we've said, can be a range of different types of content. So this presentation is largely going to be focused on some of the potential concerns and risks surrounding generative AI, but we don't want to leave you with the impression that this is a technology that's wholly without merit. In fact, there does appear to be a lot of enthusiasm for its potential. If you, like me, read a lot of insurance industry or business publications, you'll know that there's a lot of conversation and even enthusiasm around how this technology could help improve operational efficiency, or how it might be used to close some of the talent gaps that the industry has grappled with for several years now. So we want to acknowledge that there may be a lot of beneficial use cases here. Just a few examples are listed here. Generative AI tools have reportedly been used to create novel protein structures to aid in disease research, or to identify new antibodies, which could help address emerging pandemic risks. Some of these tools may do a better job at detecting and diagnosing diseases from photos or even patient descriptions of their ailments. And like I mentioned, it may have significant promise as a means to automate business functions. And this really just scratches the surface of some of the other potentially positive use cases. But that is for another day. For now, I'm going to turn this over to my colleague, Eleanor Bragg from our Arium Liability Analytics team, who's going to talk through some of the potential liability concerns we could be facing with generative AI.
Thanks, Greg. So, as Greg mentioned, there are many potential use cases for generative AI across multiple industries. However, there are also some known potential flaws that can come up when using generative AI, which I'm going to talk about in more detail soon. And there may also be more potential flaws that we don't know about yet, especially because AI tools are not always transparent in how they work, even to their creators, and because in general, it can take time for some of the negative impacts of a new product or technology to come to light. So when you have these widespread possible uses combined with possibly flawed outcomes, that creates the potential for systemic liability risks, which means risks that could impact many companies across multiple industries. These risks have the potential to impact several different lines of business, including directors and officers' liability, professional liability or errors and omissions, employment practices liability, and even product liability. So I'm going to lay out some of those known potential flaws of GAI and then explain how some specific potential use cases could lead to liability risks. And then at the end, I'll cover some of the options that exist for mitigating these risks. So the first set of known potential flaws to talk about include intellectual property concerns and privacy concerns. So on the left, there can be IP infringement concerns because the data sets that generative AI is trained on may contain copyrighted material or other intellectual property. And if that's the case, then the outputs from using these tools may share that material without the adequate permissions. And this could lead to potential liability for GAI creators and users, such as coders, designers, advertisers, and more. For example, in the past year, a class action lawsuit was filed by artists against multiple companies that created GAI tools that generate visual art. The lawsuit alleges that these companies broke copyright and unfair competition laws because they used the artist's work in training data without consent or compensation, and because the tools produce content that copies the artist's styles. In another case, a stock photo provider sued a GAI creator for allegedly scraping millions of its photos without proper licensing and using them to train the GAI tool. In a case related to computer code, some software developers filed a class action against tech companies that were using their publicly available code in order to train a GAI tool that is meant to assist with writing code by suggesting new code lines. So we've seen some of those liability issues come to the foreground already. On the right, we have the privacy and use of likeness concerns. So similarly, these training data sets for the GAI tools may contain sensitive or private data that may have gotten into the sets due to a data leak or breach. And as a result, again, the outputs could share that data without adequate permission or protections. For example, one person searching through a GAI training database reportedly found photos of herself taken at the doctor's office that apparently had leaked from her medical records. And GAI tools using someone's likeness can pose liability issues even if the source data is allowed to be public. For example, a company that uses AI to make face swap images was sued this year for allegedly violating the California right of publicity law by using celebrities' images without consent. The limited litigation that we've seen on these issues to date has targeted GAI creators, but it is possible that liability for these types of infringements could spread to downstream users as well. So that's that set of known potential flaws. The second set of known potential flaws to go over are ones that can lead to inaccurate responses from the GAI or skewed outputs from the GAI. So on the left, we have what are called hallucinations. This is an issue where GAI tools produce outputs that sound legitimate, but actually contain errors or falsehoods. For an example, you could prompt a GAI tool to find an academic paper on a certain topic, and the tool might answer with a paper title and author names that sound legitimate. But when you do your own research, it turns out that that specific paper does not exist, and maybe the listed authors are real academics, but they don't actually study the topic of the fake paper. And there's no perfect fix currently available for these so-called hallucinations. Some GAI creators are trying to hard code certain checks and balances into the GAI to reduce the chance of incorrect outputs. But right now, there's no solution that can catch everything. On the right, it's also possible that GAI tools may recreate or amplify bias that exists in their datasets. This could lead to discrimination in the tool's outputs or applications along the lines of race, gender, age, or other characteristics. This is a known potential issue with AI and algorithms more broadly. So it's also been flagged as a concern in GAI by some observers, including researchers at academic and government institutions. And it could come up in a variety of industries, including healthcare, hiring, and finance, if these tools are applied in similar ways. So these potential flaws on this slide that affect the quality of GAI outputs could present many different types of liability risks depending on the use case. So next, I'm going to go over some of those potential use cases and the corresponding liability concerns. Just as an overall note, these potential use cases that I'm going to mention are all possible applications of GAI that are on the horizon in some way. So that means some of these applications are already being implemented or at least piloted in corporate contexts. Some of these applications are being studied and tested in academic research, and some are use cases that are already widely implemented for other forms of AI, and so they could end up utilizing generative AI as well. So for the first potential use case, it's possible that GAI tools could be used for professional services. GAI tools could be used to assist with legal support services, financial advising tools, or other professional services. For example, for automating the preparation of legal documents or auto-suggesting responses to personal finance questions posed by a firm's clients. Given the potential flaws in the outputs from GAI, however, this could lead to errors or omissions in this advising or paperwork, and that could create potential liability from customers or regulatory agencies. For one example, a company that claims to use AI to provide legal services has faced multiple lawsuits this year, including a class action brought by a customer who claims to have received substandard legal documents from the service. There are also potential use cases for corporate compliance workloads for GAI tools, including forms required by regulators, financial reports to shareholders, or other communications that GAI could be used to make more efficient. In fact, at least one major auditing firm is already beginning to implement GAI tools on many of its teams, including both client-facing and internal support teams. These use cases could lead to potential liability if the resulting communications have inaccuracies or omissions, which could draw negative attention from regulators and company shareholders. This type of potential liability could implicate the directors and executives of the corporations, as well as any auditors, lawyers, or other advisors that worked for these corporations if they failed to catch flaws in GAI-assisted work. To move on to a pretty different example use case, there are also multiple potential use cases being explored for GAI tools in healthcare systems. So on the left, GAI tools may be able to take notes on doctor-patient visits, summarize other patient data, or respond to patient messages, with the hope of saving healthcare providers time. There are multiple tools of this kind currently being developed and tested by private companies. On the right, a more radical potential use case is to have GAI tools assist with medical diagnostics and decision-making. This application may be further off in the future compared to note-taking tools or chatbots for simple message conversations. However, at least one diagnostic GAI tool is currently being piloted by a private company. And it should be noted that although these are not generative AI, algorithms are already used in existing healthcare systems to make decisions, and these existing uses have already raised concerns about errors and bias. For example, academic research has looked at algorithms that hospital systems use to prioritize patients for certain care programs based on their level of need. And it was found that the algorithms underestimated the severity of illness in Black patients compared to white patients, leading to decreased access to serious care such as kidney transplants for Black patients. So there is already some precedent for medical use of a similar tool with resulting problems in the outcomes. If the potential flaws in generative AI tools make their way into medical outcomes, there could be potential liability for medical malpractice and/or discrimination. There are also many potential use cases for GAI tools in product design and manufacturing. GAI tools may be used to help design chips, write code, manufacture cars, design buildings, discover new drugs, and more. And again, if there are these potential flaws in the GAI tools, that could lead to flawed designs or faulty production processes. That in turn could lead to potential liability for the designers, manufacturers, distributors, or advertisers of these products or designs. So now that we've gone over the different potential use cases on the horizon and the liability risks that come with them, it's worth asking, could these risks be mitigated? The answer is they can be mitigated somewhat. So first of all, the capabilities of current GAI tools may improve going forward. The creators may be able to make them less blunt tools, may be able also to develop best practices for the most effective ways to prompt the tools, and users may gain literacy over time, meaning that users could get better at knowing how to prompt these tools to have the most accurate and unbiased outcomes. Also, many companies are likely to do human review when they're using these GAI tools. They're likely to do quality assurance, product testing, and other forms of vetting in order to catch any flaws that are in the GAI-assisted work before they sign off on it. It's also possible to fine-tune the data sets or to fine-tune the GAI tools on narrower data sets, and that may increase the precision of a GAI tool for a given application. In some cases, specializing the tool in that way may make it less likely to produce unforeseen errors, biases, or intellectual property or privacy infringements. However, not every flaw can be prevented. As we went over earlier with the problem of so-called hallucinations, there are not necessarily perfect fixes available for the known potential flaws in GAI tools. And you can't prevent flaws that you can't anticipate. The flaws in GAI may be difficult to anticipate due to the fact that AI tools are not always transparent. AI tools, especially large language models, can be so-called black boxes because their processes of transforming inputs into outputs are so complex that humans cannot explain the steps of those processes. attempting to make them explainable is an ongoing challenge for the AI industry. There are also challenges involved in testing and judging the quality of the AI tools being developed today. Some researchers of AI have suggested that the current benchmarks used in the industry to determine effectiveness of AI tools are becoming saturated, meaning that many current AI tools can perform successfully against many existing benchmarks of quality, even though those tools still have major shortcomings. AI researchers are still working on improving the standard methods of judging a tool's quality. Lastly, upstream generative AI applications may fall under the radar of businesses down the supply chain. Some companies are currently taking steps to make this less likely. For example, some advertising agencies are pushing others in their industry to disclose when they have used GAI by encouraging disclosure through voluntary campaigns or by making it a contract requirement. However, there may be many other business areas in which more disclosure may be needed before businesses can really be sure whether they are or are not using GAI. So the takeaway is that given the positive potential for GAI and the excitement around it, it's going to keep moving forward. These tools are going to keep being developed. And given these inherent challenges in these tools, the potential for liability risk is here to stay as well. And with that, I'll hand it back to Greg, who is going to discuss a whole separate set of risks that can arise from the use of generative AI.
Okay, thank you, Eleanor. That was very interesting. So for my half of the presentation, I'm going to discuss what happens when generative AI works just fine, but rather than possible mistakes, we're going to highlight some of the potential concerns when this technology falls into the wrong hands or when it's used to influence a trend like social inflation or civil unrest, which may be of interest. So first up are some cyber concerns. And the overall moral of the story here is that many of the existing avenues for cybercrime and social engineering that we may all be aware of become easier and more effective if attackers leverage generative AI. So according to one cybersecurity research firm, there's already been a 61% increase in phishing attacks since October of 2022. And these attacks appear to be growing more sophisticated thanks in part to the use of generative AI. So generative AI tools may need as little as 3 seconds of the sound of a person's voice, maybe taken down from a social media post, to build a plausible sounding but completely fake voice clone. And the Federal Trade Commission has been warning since about March of this year that there's been a rise in phone scams employing these fake voice clones. You can read horror stories in the media of individuals who thought they were talking to family members when in fact they were interfacing with scammers using voice clones. Let's take another type of common cybercrime, and that's phishing. So many types of phishing or other social engineering schemes usually rely on email or text message. And sometimes the author of those messages may not have a firm command of the native language that they're authoring in, or maybe they're just not sticklers for grammar. And so some of the errors that they introduce in their messages can help human or automated systems detect the presence of phishing. But now, in an era of generative AI chatbots, cybercriminals can use those chatbots to craft more compelling, error-free prose and better elude both human and automated defenses. And then there are deepfakes, which are artificial representations of real people. In this case, it's not just their voice clone, but a whole video and voice acting as one. And deepfakes are already circulating on social media, but there's also the potential for these deepfakes to be used in what are called phishing attacks or video phishing attacks. So let's imagine a scenario where you get a video call from someone asking for sensitive information. The person looks and sounds exactly like your manager, but isn't. They are a deepfake. According to one cybersecurity firm, there's been a 144% increase in phishing attacks in the fourth quarter of last year, and some experts see this as a new frontier for cybercriminals since these types of attacks are harder for automated systems to detect, at least for the time being. As we mentioned earlier, one of the outputs of a generative AI model can be computer code, and that code could potentially be malware. So many public chatbots have safeguards that prevent them from responding to a prompt asking for malware. However, there have been demonstrations by some cybersecurity experts that reveal that certain prompting sequences can get around those safeguards and you can essentially prompt the model into delivering malware code. Then there's the possibility that open source generative AI models, the kind we mentioned earlier that enable the general public to see and interact with the underlying source code, that these open source models could be fine-tuned by nefarious actors for malware. So imagine a chatbot that doesn't just spit out poems or term papers, but actually spits out malware on command. So this could lead to situations where individuals who have little or no coding experience could interact with these models and receive malware code from them. Or someone with sophisticated coding experience could use these models to further fine-tune or improve their code, or even help them automate larger scale attacks. So we mentioned deepfakes a bit earlier. The ability to build a deepfake may not only be used to fool people, but it may also be used to fool biometric security systems that may rely on things like faces or voices to authenticate a user. And unlike a password, which you can change, your biometric markers, your face, your voice, are not likely to change much. So we know today that there are thriving dark web markets for stolen passwords and other personal information. So we have to ask, will there be a dark web market for voice and face clones in the near future? And lastly, so I mentioned earlier that generative AI models can contain large amounts of data from the internet, and some of that data can be from private sources. Some cybersecurity researchers have indicated that it's possible to extract this private data from models using what's dubbed a training data extraction attack. So using these attacks, researchers were able to pull personally identifiable information, that's names, phone numbers, email address, and other sensitive information right from a chatbot, even when that information was only available in a single document among millions of gigabytes of data. So this attack was demonstrated on a very popular large language model, albeit an older generation. But the concern here is that if companies adopt these models, these chatbots, even fine-tuned versions of them, versions that have been trained on the company's data, for public-facing use, a data extraction attack could be leveraged against these companies and possibly put them on the hook for exposing private information. And there's another type of malicious prompt, which is basically a method to make a chatbot go off script. So if you have been following this technology in the news, you may remember earlier this year in February, a media outlet published an interview transcript between their tech reporter and a generative AI chatbot. And in that exchange, the reporter was able to prompt the chatbot in such a way that it began to provide odd responses. At one point, it professed its love for the reporter and insisted that the reporter get a divorce. So this kind of prompting, where an individual essentially breaks the expected functioning of the generative AI model, could potentially be used by bad actors on any public-facing generative AI chat interface to elicit unexpected reactions, and then use those reactions to damage a brand or maybe even extort an organization. And the final cyber concern we can mention here is data poisoning. Now, this is a vulnerability that is subject to a variety of machine learning systems, not just generative AI, but it refers to attempts to interfere with a model in its training phase by either feeding it erroneous data or sending it incorrect signals. So for example, let's say we have a chatbot that asks you to verify whether its response was correct to help it improve. If you're a data poisoner, you could signal that an incorrect response was the correct one and interfere with the model's training. And if this is done in a concerted effort over time, it could interfere with the accuracy and quality of the model's output. And ironically, generative AI might be poised to poison itself. So let me explain. There have been media reports about a huge groundswell of low-quality websites built using generative AI text. It's basically an attempt by people to spin up websites to capitalize on advertising revenue that flows through digital ad networks. So, and as Eleanor mentioned, generative AI is not infallible. It can make errors, it can hallucinate. So if the internet is, if not filling up, then at least growing more crowded with AI-generated content, some of it of questionable accuracy, what happens the next time the internet is scraped for training data for new generative AI models? Well, it's going to scrape up a lot of generative AI content. Now, the internet was not necessarily awash in perfectly accurate and unobjectionable material to begin with, but the result may be that generative AI outputs grow even less accurate and more problematic the more generative AI content gets fed back into the internet. Sort of an ironic problem. But these are examples of generative AI concerns when it falls into the wrong hands. Generative AI could also be used to influence trends that some insurers may be concerned with, such as social inflation. So one use case for generative AI is in the legal profession, possibly helping legal teams analyze cases or craft documentation. And one possible consequence of this development may be an increase in the frequency of litigation by essentially making it easier for individuals to sue or join class action lawsuits. So for example, there's an AI chatbot that promises to offer legal advice and let individuals, quote, sue corporations at the touch of a button. We may even see a severity impact from this. So generative AI analytical tools could analyze past cases or settlements, help identify elements that made them successful, and then look for those elements in prospective cases and do this at scale, so more efficiently. It may also be used by litigation funders to help determine where they should direct their capital. In fact, there are reports of just such a tool being used in India today. Another possible concern is that generative AI could help contribute to civil unrest. So in the past, we know that there are reports of online disinformation that contribute to real-world violence. And generative AI tools may make it easier to create and spread even more realistic-looking disinformation through online spaces, which may heighten the risk of incidents of civil unrest. Another possible concern is that generative AI tools lead to widespread disruption in the labor force. One published estimate earlier this year suggested that generative AI tools could impact 300 million jobs globally. It's basically an American population's worth of jobs. So to the extent that generative AI potentially contributes to higher unemployment or maybe greater economic volatility, it could in turn help contribute to social turbulence. There's also the possibility that generative AI disinformation could be used to deliberately engineer financial panics. And actually, this may not be a possibility. It may have already happened. So in May of this year, an AI-generated image of the Pentagon on fire was circulated by some social media accounts, including one social media account that was masquerading under the guise of a reputable financial media publication. So as this fake image spread, the stock market dropped. And this was a temporary drop, but it was suggestive of the power that a single fake image can have. Now, we can use our imagination and hypothesize a more coordinated campaign that leverages multiple generative AI media types, inauthentic news publications, even live on the scene reporting generated by AI that's completely deepfake. And you can imagine that this misinformation leads to a long enough downturn in the market that an opportunistic short seller could capitalize. And these attacks don't have to be aimed broadly at the stock market, but could be aimed at specific companies or even individual corporate officers to cause chaos and disruption. The possibilities appear endless. Okay, so for this last section, we're going to touch on what we can call horizon risks. As in, these are the potential risks that some experts see on the horizon as artificial intelligence advances. There have been at least 2 open letters from business leaders recently, including AI researchers, academics, engineers, others in the field, that have highlighted some of the potential risks that artificial intelligence may pose to human society. One letter, published a few weeks ago, equated the risk from AI to a pandemic or a nuclear conflict, so a major catastrophe. And there are a variety of potential concerns here, but we only have time to walk through a few. And while each of these are unique, they revolve around 3 interlocking assumptions. The first is that AI systems will continue to improve. The second is that as these systems improve, we'll continue to use them for automation, including the automation of certain business operations or even critical infrastructure. And the final assumption is that in each case, there's either an unexpected action or a loss of at least some level of control over these systems. And during that time, you could see an AI system potentially cause harm or damage, maybe even catastrophic levels of damage, depending on how much time it's out of human control or what other systems it may have access to. So with that in mind, let's walk through these 3 concerns. The first is something called proxy gaming. And this generally describes when an AI system is given a goal and attempts to achieve that goal in a way that winds up creating unexpected harm. So the goal doesn't have to be harmful. In fact, it could be perfectly benign, but the measures taken to achieve it may cause unexpected harm. So we do have an example of this concern today. One AI firm reported on an experiment it conducted where it gave an AI the task of winning a video game where it piloted a boat. And the goal was achieve the most points in this boat racing game. So the AI generally achieved that goal. It reportedly scored an average of 20% better than its human counterparts. But it did so by employing a strategy that repeatedly crashed its boat into other boats, caused its own boat to catch on fire, and to travel in the wrong direction in the course. So the moral of the story is, just because you've given this system a goal doesn't mean it will achieve the goal in ways that don't cause unexpected harm. So that's unexpected consequences. There's also the possibility of unexpected functionality, or what some have called emergence. So emergence generally refers to an AI system that gains capabilities that were not anticipated by its developers based on the prior capabilities of similar but smaller models. So in that case, the abilities are said to emerge. And there is some research suggesting that emergence may already be occurring in some of the newer large language models. Now, in that case, the abilities that have been reported to emerge are generally benign. They're things like the ability to perform more sophisticated mathematical calculations. But the concern is that a loss of control scenario becomes much more likely the more these systems behave unexpectedly and the more these systems have to do. So for example, you get a surprising result from a chatbot, that's one thing. You get a surprising result from a law enforcement robot or a program that's integrated with critical infrastructure, and that's quite another. It's also important to keep in mind that emergent capabilities may not be discovered until after an AI product is deployed. So for example, some large language model capabilities that have been reportedly characterized as emergent were only discovered after the model was accessible to the public. And finally, there's a concern around what some AI researchers call an intelligence explosion. So it's a term that's been attributed to the late computer scientist Irving John Good. Today we know that in some domains, AI is superior to human performance. Good luck trying to beat an AI in chess, right? It's probably not going to happen. However, for the moment, AI is generally domain specific. So you have a great chess playing AI, it may not also be great at piloting a boat or making a medical diagnosis or designing semiconductors. But there is a push by some developers to make singular AI systems that exceed human capabilities across multiple domains and do so by a continuous process of training, recoding, and training and recoding. So the intelligence explosion hypothesis is essentially that this process succeeds, that we're able to build AI systems that continually get better across multiple domains. And by better, I mean better than human performance. So you have a single AI system that exceeds human intelligence across multiple domains. If one of those domains happens to be building AI systems, you could face the possibility of a rapidly improving AI system that continues to become ever more capable and surpass more and more human capabilities. And the concern is that as these new capabilities accumulate, situations where you have emergent capabilities or proxy gaming scenarios become much more likely. It's also more likely for the AI to become disruptive because it may have access to more real-world systems where it could cause harm or where humanity could lose at least some measure of control. So, as I mentioned, this concept was credited to computer scientist Irving John Good, so maybe it's fitting to leave you with Good's own thoughts on this. He's reported to have written that, quote, "The first ultra-intelligent machine is the last invention that humanity need ever make, provided that the machine is docile enough to tell us how to keep it under control." Good continued, "It's a curious thing that this point is made so seldom outside of science fiction. It's sometimes worthwhile to take science fiction seriously." Thank you for joining our webinar on generative AI today. If you have any questions on this webinar or are interested to learn more about how Arium models systemic liability risk, our catalog of over 300 liability events, including the research on generative AI and other emerging risks, then please contact us at the email address on your screen, ariumsupport@verisk.com. You can also stay informed on emerging risks through Verisk's Emerging Issues website and newsletter. You can subscribe to those at core.verisk.com. Thank you.
Thank you for joining us for today's webinar. For any of your colleagues that may have missed it, a recording of today's presentation and slide deck will be available on demand. Please provide your feedback. Thank you and have a great rest of your day.